So these are absolute value equations we're going to be talking about, and absolute value equations are a little more tricky. And the thing is, what's the absolute value? Well, it's actually what we call a piecewise function. It has two different values depending on what x is. The absolute value of x, and this is the formal definition that we use in higher mathematics, it's equal to x if x is greater than or equal to 0. That means if x is positive, it's just equal to x. It's equal to negative x if x is less than 0. So here's what we call, again, a piecewise function. Here's an example. The absolute value of 4, well, is 4 greater than 0? Yes, 4 is greater than 0, so it's just equal to 4. All right, what's the absolute value of negative 4? Well, negative 4 is less than 0, so it's equal to negative 4. And what's the negative times the negative? A positive, so it's also equal to 4. So we have two numbers here that can have an absolute value of 4. So when we have an equation like the absolute value of x equals 7, we have two possibilities. Because what number has an absolute value of 7? Well, 7 does, because the absolute value of 7 is 7, and negative 7 does, because the absolute value of negative 7 in the same way would also be 7. So when we see something like this, in order to remove the absolute value bars, you need two equations. You can think of one equation for each bar. The first bar gives me this equation, x can equal 7, or this bar, x would equal negative 7. And you could check that. The absolute value of 7 is 7, and the absolute value of negative 7 is 7. So that's what you have. So when you have absolute values equations, you usually have two solutions. All right, so let's try another example. How about the absolute value of x minus 3 equals 5. Okay? So we say, well, what two numbers have an absolute value of 5? Well, x minus 3 could be 5, because the absolute value of 5 is 5. Or x minus 3 could be negative 5, because the absolute value of negative 5 is also 5. So I've got these two possibilities, so I just solve these equations. Now when you solve these equations, the left sides are always going to look the same, so you're always going to be doing the same thing to both equations. So I'm going to add 3 to both sides, or I'm going to add 3 here to both sides. The right sides would be different. One would be positive, one would be negative, so that's where you're going to get your different solutions. All right. So a negative 3 and a positive 3 are opposites. Those are 0, so we just end up with x equals, and 5 plus 3 is 8, or x equals, and negative 5 plus 3 is negative 2. Now go back and check this. If I put 8 in here, what's 8 minus 3? 5. What's the absolute value of 5? 5. If I put negative 2 in here, what's negative 2 and negative 3? Negative 5. What's the absolute value of negative 5? 5. So both solutions work. And sometimes if we put this in a solution set, or what we call a truth set, we could write 8, negative 2. Remember, a set is just a collection of objects. And that's the truth set, and we call it the truth set because these are the values that make this a true statement, that the left side does indeed equal the right side. That's our truth set. Okay, now all we want to do is get to this step where we have the absolute value isolated, and then we'll be in good shape. So if you have a problem like this, here's a little bit more complicated problem. Okay, then what we want to do on this problem here is we want to isolate this and make sure we just have the absolute value. We want to get to this point here, and then we'll have two different equations. So we treat this like a regular equation. If I want to solve for this is like my variable now. This is what I want to isolate. Then I have to remove the negative 5 and the 2 times. That's what it's next to these times. So this is the weaker of the operation. So what I would do is I would just add 5 to both sides. And on the left, I've got 2 times the absolute value of x plus 4, and this is 0, and that equals, and 13 plus 5 is 18. And then I want to isolate this, so this is joined by times. The opposite of times is divide, so I'll divide both sides by 2. And I end up with 2 over 2 is 1, so I just have the absolute value of x plus 4 equals, and then 18 divided by 2 is 9. Now remember, this always has got to be a positive. If you have a negative number here, then it's no solution because the absolute value is always positive. So remember that if you end up with a negative here, no solution. Okay, then I know I have two possibilities. Either x plus 4 can equal 9, because the absolute value of 9 is 9, or x plus 4 can equal negative 9, because the absolute value of negative 9 is also 9. And again, we'll just subtract. Four from both sides of both equations. So that's 0, x plus 0 is x, so I have x equals 9 minus 4 is 5, or x equals negative 13. So those are my two possible answers. And like I said, I could put that in a solution set. 5, comma, negative 13. Or you could put the negative 13 in the front, because in sets it doesn't matter what order you put those in. Now you can always check this. Let's say I put 5 in here. What's 5 plus 4? 9. What's 2 times 9? 18. What's 18 minus 5? 13. You could put negative 13 in here. Negative 13 plus 4 is negative 13 plus 4 is negative 9. But the absolute value of negative 9 is also 9. 2 times 9 is 18. 18 minus 5 is 13. So both numbers will check. Okay? And you could have, this could be as complicated as possible, but once you have it isolated, then you just solve these simple equations. So I hope that makes sense for absolute value.